Welcome everyone to the Insight Stream. This is podcast number 3 of the series that is being organized by the Bhaktivedanta Institute for Higher Studies based in Gainesville, Florida. And I'm fortunate to be here as a host. Thank you for inviting me. I'm Kunal Mooley, an astrophysicist and the co-founder of IMIX, which is the Institute for Mind, Intelligence, and Consciousness Studies. And today we have an esteemed speaker and guest, Stuart Hameroff. So, Stuart, welcome. And
Thank you.
it's my pleasure and honor to be introducing you today. I
It's good
hope
to
everything is
be here.
well back in Arizona.
Things are going very
It's
well. Thank you. It's a beautiful day.
fantastic. So, our very esteemed guest, Stuart Hameroff, grew up in Cleveland, Ohio, and attended University of Pittsburgh as an undergrad. And then he went on to do med school at Hahnemann Medical College, which is now Drexel as I know it, in Philadelphia in the early 1970s. He then did his residency in the Department of Anesthesiology in 1975 at the University of Arizona and finally joined as a faculty member in 1977, where he held this position as a faculty and practicing anesthesiologist at the Banner University Medical Center for many years. And after about 50 years, he is now retired. And basically, Stuart has joined the Arizona Astrobiology Center at this university, looking for the origin of life and consciousness in the universe, asking the question, which of these came first, life or consciousness? This is very fascinating, very interesting topic, Stuart. And again, it's going to be a fascinating conversation, this one. Okay, so I'm going to request you, Stuart, to maybe begin with giving us some insights on consciousness, your very famous theory of orchestrated objective reduction, along with Roger Penrose, and what are the latest research results that you have to share. And you've been running this wonderful and successful Center for Consciousness at UA, along with this Science of Consciousness conference that has now been running for 30 plus years. So we want to hear all about it. Stuart, please.
Okay, thanks, Kanal. Great to be here. Hello, everybody. So I got interested in consciousness in undergraduate and did in medical school. I was interested in the brain-mind disciplines like neurology, psychiatry, neurosurgery, but I stumbled into anesthesiology because of my interest in consciousness. And I was convinced by my future chairman, a man named Bernell Brown, that the best way to figure out the science of consciousness is to figure out how anesthesia works. Because under anesthesia, there's no consciousness, but the brain is still active. So there's something going on in the brain that that is sensitive to anesthesia, and what is that? It's not just neuronal firing. It's not just membrane activity. And the basic view of most neuroscience and philosophy is the brain is a complex computer of simple neurons, and each neuron is like a 1 or a 0. It takes in information, integrates through a threshold, and then fires, and that goes to the next layer of neurons. And if it fires, that's a 1. If it doesn't fire, that's a 0, or at least that's what people have kind of extrapolated to, so that the brain can be made to look like a computer with axonal firings and synaptic transmissions like a 1 or a 0. That ignores what's happening at everything inside the neuron because it only looks at the membrane, and it only occurs at one frequency range, which is in hertz, like EEG range, from 0 to 100 cycles per second, maybe a few hundred. And but if you look inside the neuron, you see these structures called microtubules, which are fill the neuron. They're kind of the skeleton of the microtubule, like our bones are the skeleton. But they're also the information processing system, and seem to be the intelligence. And evidence now shows the home of the site of consciousness in the inside the neuron and inside the brain. Due to what? That's the question. So I got interested in these microtubules, which kind of look like a hollow ear of corn with kernels, next to each other in kind of a lattice, except it was a cylindrical lattice with Fibonacci geometry, this mathematical patterning. And when I was in medical school, I studied mitosis and cell division and how the cell divides and the mitotic spindles, which are made of microtubules, pull the chromosomes apart. And this has to be perfectly done so that you have exact duplicates and each goes on to form a daughter cell and proliferate. And that's how embryos grow and everything grows by cell division generally. Well, not everything, because neurons don't divide once they're formed. So the mitotic spindles were key, and they seem to have to know where to go and what to do. They seem to need some kind of information processing. And everybody else in the lab got interested in the chromosomes because of genetics, and it was the dawn of the genetic revolution. But for some reason, I fixated on these microtubules and how they might process information. And when their structure was learned to be this lattice structure, it kind of looked like a computer matrix to me. I was trying to learn about computers, which were new back then, at least to me. And they looked like a Boolean switching matrix or something like that. And each tubulin, each peanut-shaped protein within the microtubule could communicate with its neighbors and process information. At least we proposed that. And I worked with physicists to model microtubule automata information processing at a deeper level inside neurons. And I was trying to see what anesthesia did, which I eventually did get to test. But in the 70s and 80s, I went around with these simulations and models of information processing to AI meetings and neural net meetings where they were trying to model the brain as a computer. And according to them, to artificial intelligence and Ray Kurzweil, the singularity and all that, and even now today with the LLMs and ChatGPT and everybody, all those guys, machines, they were saying that the brain is got about 100 billion neurons, each with about 1,000 synapses and operating at about 100 hertz. So that's 10 to the 16th operations per second. So they were saying the brain is a computer operating with 10 to the 16th operations per second, each firing being like a bit. And when we can have a computer equivalent to that with 10 to the 16th operations per second, we'll have brain equivalents and consciousness. And so, give us a couple more billion or trillion dollars and we'll do that. And you can have a conscious computer and maybe deposit your consciousness and be immortal. That was kind of the selling point, which was all a bunch of baloney, I think. And anyway, I was going around saying, no, there's actually inside every neuron in a brain, there is a billion tubulins switching at about 10 megahertz. So 10 to the 16th operations per second per neuron, what they were saying for the entire brain. And I was saying, so your target's way, way downstream to get brain equivalents. Well, they didn't like that very much and pretty much told me to get lost. And I was kind of a pain in their thorn in their side. And but one day somebody said, well, let's say you're right. And how would that explain consciousness? How would that explain feelings, love, joy, emotion, everything that we know that consciousness is: experience, phenomenal experience, qualia, choice, free will, etc. Because it's just still what I was saying back then was still more computation at a deeper, more intense level. And I was a bit stunned by that and realized that this person was correct. And but he fortunately recommended I read a book by Roger Penrose, The Emperor's New Mind, which basically argued the first half of it that the consciousness was not just a computation, that there was something more to it because and he used Gödel's theorem, which showed that a mathematical theorem can't prove itself. You need something outside, like a mathematician, to judge it whether it's true or not. And so he kind of extrapolated that to say that understanding a mathematical equation or just conscious understanding is more of a feeling than it is an algorithmic process. And that consciousness could not be algorithmic for us to be creative and have free will and consciousness and so forth. And therefore, he needed some outside system to come in for consciousness to provide this non-computable factor that could a place for consciousness. And for that, he said in the second half of the book, he and we have to leave classical physics and look at the quantum world. and in particular that the answer might lie in the solution to yet another mystery, the measurement problem in quantum mechanics. So he was later criticized, as I was when I teamed up with him, for invoking what David Chalmers, one of our critics, said was the mythical law of minimization of mysteries. We were taking one mystery and using it to solve another mystery. And in fact, yes, we were. But what's wrong with that? Occam's razor would say one solution to two mysteries is better than no solution. But anyway, the book it argued for this quantum collapse, and I didn't know much about it at the time, but started studying it, and I'm still studying it, and nobody really understands collapse of the wave function, as you know, Kunal. In fact, Richard Feynman, who was at Caltech where you were, maybe still are, famously said anybody who claims to understand quantum mechanics is either lying or crazy, and because it's so bizarre, so counterintuitive. So, in a nutshell, our world seems to be divided into two realms. And we have our familiar classical realm that we're in, where everything is in definite state and predictable, and particles are in one place and one state at any one time. And everything follows the predictable laws, Newton's laws, gravitation, Maxwell's equations, the gas laws. The universe works, is predictable. However, at the small scale, and exactly how small was the question, remains a question, things are different. And particles can be in multiple places at the same time in quantum superposition. They can exist as waves of multiple possibilities. They can be entangled over distance by non-local quantum entanglement, which Einstein called spooky action at a distance, because it seemed to invoke instantaneous signaling, and condensation, where particles can condense into a unitary object, which would be very helpful in the brain for binding, for pulling all this information together into unitary conscious thoughts. But the problem was, and still is, if you have superposition, if you have things in multiple places or states at the same time, when we don't see that in our everyday world, we see everything in one place. And there seems to be some cutoff or some event between the quantum and the classical, some boundary. And in the end, I think that boundary is actually consciousness. It kind of dances on the edge between the quantum and classical worlds. And I got that quote from someone who studied the Kabbalah and told me about it. I looked it up, and it's very interesting. They have two worlds of misery and strife, which could be our classical world, and then a quantum world, which could be more spiritual. And our consciousness kind of danced on the edge. And that's kind of the boundary between the quantum and classical world. So what could that be? Originally, quantum pioneers like Eugene Wigner, John von Neumann, and Bohr to some extent, not totally, said that conscious observation, well, first measurement, but then conscious observation caused multiple possibilities to collapse. The collapse of the wave function, the consciousness caused collapse. And that was a pragmatic solution. And Bohr liked that because they could ignore the underlying reality and go on and make electronics and all the gadgets we have today, which came out of quantum mechanics. So we're glad about that for sure. But he didn't care about the underlying reality. But Einstein did. He wanted to know, how could particles be in multiple places at the same time? So and that remained a mystery for a long time. But Einstein actually came up with the answer, whether he realized it or not, according to Roger, because Roger approached the problem of superposition by bringing in Einstein's general relativity, which basically says that particles, at least large particles like the sun, curve space-time, and that there was some underlying fabric of the universe, some continuum, space-time metric, I think he called it, space-time continuum, space-time geometry, some people call it, that if you go down in scale, smaller, processes get faster, but then you reach a limit, or most people think you do anyway, at the Planck scale, 10 to the minus 33 centimeters, and frequency of 10 to the 43 hertz. So very fast, very small. And it seems to be coarse, have some irregularities, and therefore could be laden with information. And Roger said that indeed that the well he put the he approached the superposition problem by bringing in this curvature, which Einstein applied to giant things, and that was proven in a famous experiment in 1919 by Eddington. I'm sure you know this. So the if here's the sun, a star is here, and we're here. The sunlight, the starlight would curve around the sun because of the curvature, and we would see it down here. Einstein predicted, and Eddington did the experiment during an eclipse on a mountaintop, and sure enough, saw these stars off to the side when they were known to be behind the sun. Space-time curved it. So Roger applied that to tiny things. He said, okay, the sun can have big curvatures. An electron or a proton or a neutron or something could be it could have a tiny curvature. And if it was here and here in two places, it would have curvatures in both directions. And this would imply, according to Roger Penrose, a separation in fundamental space-time geometry. The universe at its most basic level would separate and would continue up to a point at least. Now, some people think that there's no collapse and each possibility goes off and evolves its own universe. This is the many worlds hypothesis, which, as you know, is very popular among physicists. It avoids consciousness, it avoids collapse, and you can kind of ignore some of its implications. But anyway, Roger said the separations, no, they won't continue. They're unstable and will collapse after time t to this one or that one to pick this local reality or that local reality. And when that happened, and this was the big step, there would be a moment of conscious experience. That this was where qualia experience, phenomenal experience came from, the fundamental level of the universe with these little collapses, these quantum state reductions due to an objective threshold at time t equals h bar over e sub g, where h bar is Planck's constant over 2 pi, the Planck-Dirac constant, and e sub g is the gravitational energy of pulling a particle apart from itself or separating this equivalent space-time. So the bigger the separation, the smaller the t and the faster the collapse. So a large separation would reduce very quickly. A small one might take a long time, assuming it could be isolated from other quantum operation processes going on. And when this happened, according to Roger, in the random in the microenvironment where the quantum forces are kind of random, the experience would also be random. It would be spurious, could be anything, and it would be disconnected. There'd be no memory. It would come and go, and this presumably is happening all around us. This, and he called it proto-consciousness. Proto-conscious events are happening in the microenvironment everywhere, in the air, in the table, in everywhere. But it would be kind of a background proto-conscious noise, kind of like panpsychists say that there's consciousness on every piece of matter, but then you got to define the matter and which matter and how and so forth. That gets you into problems. But if you say it's in the collapse, which defines the state of that matter, then it's a process. It's not a condition or a particle. It's actually a process. And consciousness does seem to be a process, a sequence of events. And each collapse could be like a frame if there were memory. So anyway, the proto-conscious noise needed, according to Roger, something in the brain that would organize or orchestrate it. And so I kind of look at that now as the proto-conscious noise. If you go to the symphony and the musicians are tuning up their instruments, you hear kind of a cacophony. They're making all these, trained musicians know they're tuning to A or something, which I don't understand. But to me, it's kind of noise and a cacophony. And it would be analogous, I think, to the proto-conscious noise in the universe at large. Now, there could be organized, orchestrated consciousness in the universe outside of our bodies, but that's not what I'm talking about now, and that's another leap. But for the moment, just think about this proto-conscious noise. It would need to be orchestrated, like the sounds of the musicians tuning their instruments needed to be orchestrated by the symphony the music that's written down that they followed, the score, and the conductor, although you don't necessarily need a conductor in the brain, but basically it turns this noise into beautiful music of any kind. Bach, Beethoven, Indian ragas, rock and roll, whatever, and music is very emotional and makes us feel, and so it's a metaphor. But I think actually the microtubules inside the neurons in the brain uh, orchestrate these objective reductions and these protoconscious events and make and entangle them into a unitary conscious entity. So a large E sub G in a fairly fast time T. So anyway, Roger and I suggested to him that he needed microtubules. He asked in the book basically what in the brain could possibly do this, and I wrote him a letter and said I think it's microtubules, and I told him about them. And anyway, we soon met, and he liked the idea, and we teamed up and developed our theory in the mid '90s. And it was basically the idea was that the microtubules would orchestrate these objective reductions and turn this into kind of a symphony in space-time geometry in the fabric of the universe with resonance and so forth within our own brains. But it was also quantum, so non-locality. So we could also extend out between people, among people, and even with the universe itself, and perhaps with a spiritual being and so forth. Although Roger doesn't like to talk about that. So anyway, we started publishing on this in the mid '90s and were immediately ridiculed and criticized because they said everybody knew that the brain is too warm, wet, and noisy for quantum effects. Because if you want to build a quantum computer, you have to do it at absolute zero temperature, which people do to avoid any oscillations from thermal heat. But I knew about a theory of biological coherence from a guy named Herbert Froelich in the 60s and 70s, who basically said if you have a lattice, a biological lattice with periodic spacing of nonpolar groups like aromatic rings and proteins, they would tend to oscillate just from background thermal KT, the energy available at ambient and biological temperatures would cause them to oscillate not randomly, but because of the structure, they would oscillate coherently, and kind of like a laser even. And that would be a quantum state, a quantum coherent state, a unitary state, which could account for why, for example, we have all these processes going on, looking at bringing sensory information, process different places, times in the brain, but yet we see one unitary object. So you see something in the sky, you see its shape, color, its motion, meaning, but you don't process those separately. You say, it's a silver airplane, or it's a blue bird, or it's a kite, or whatever it is, and you see that instantly as one object. So you need some kind of entanglement in the brain for that. So anyway, people criticized us. There was a famous criticism by a well-known physicist named Max Tegmark, whom I'm sure you know, who I think was trying to take down Roger like a Wild West gunslinger might try to take down the sheriff or the top gunslinger. But anyway, he failed miserably because he predicted that microtubules would decohere in 10 to the minus 13 seconds, according to his equation. But he made a mistake of 7 orders of magnitude, and we took his same equation and published in the same journal a year later, showing it was more like 10 to the minus 4 seconds or 10 to the minus 6, which has now been shown experimentally. So anyway, but nonetheless, people keep still to this day say, well, Tegmark proved you wrong because he's got a big megaphone or a big mouth and just keep saying it, I guess. But anyway, and then other people said it too, and AI didn't like the idea, and so we've been, but Roger and I both have tough skins, and I didn't have to depend on grants for my survival. So I just kept doing what I believed in rather than what I thought funding agencies would want. So
Yeah,
I
that's
think,
great. That's
go
great.
ahead.
Yeah. So as far as I understand, there have been many criticisms for Orch OR, but you have given responses to almost all of them instead of, if not all, right? So, but one of the important points that arises is this is great. I orchestrated Orch OR. I find it one of the very interesting theories out there for consciousness. How does one experimentally understand consciousness, or from an Orch OR perspective, how does one scientifically validate that theory? And what do you think would be the next breakthrough in the scientific understanding of consciousness?
I think the best way to prove or test any theory of consciousness is to see what goes away with anesthesia. We can't directly study or measure consciousness, much like you can't directly measure or study a quantum system, because when you make a measurement, it collapses, it goes away. But we can study what goes away with anesthesia, because anesthesia is selective. When you put a patient to sleep or an animal, the consciousness is gone, but the brain is still active. In surgery, for like spine surgery, when the surgeons were operating on the C spine, we'd have neurophysiologists come in, and they put electrodes and stimulate the fingers and the feet and record from the brain to make sure the signal was getting through the spinal cord, but they're recording from the brain. So they're getting these evoked potentials in the brain for these signals without consciousness. So the consciousness was gone, but the brain was still active. So that tells you right there that normal axonal firings and EEG type activity isn't consciousness. But what is? It turns out that Anirban Bandyopadhyay, whom you know, working at the National Institute of Material Sciences in Japan, started studying microtubules and found coherent oscillations in them at multiple frequencies. So, as I said, most people say the brain works in EEG frequencies up to maybe 100 hertz. But Anirban found that if you look deeper around the microtubules, or even away from them, but look in the right frequency, you find self-similar resonance patterns, vibrations in not only hertz, but kilohertz, 1,000 hertz, megahertz, 1,000,000 hertz, a gigahertz, 1 billion, and terahertz, 1 trillion hertz, cycles per second. And these repeated in this self-similar pattern, a triplet pattern, 3 peaks. Each peak had 3 peaks. So triplets of triplets at kilohertz, megahertz, gigahertz, and terahertz. And it's now looking like this is because microtubules are what are known as time crystals. So time crystals, I think, are going to be the next big thing. But in biology, in life and consciousness. But anyway, so we know these vibrations are there, and we know we need quantum effects in microtubules for Orch OR. Now, we can't yet measure the collapse itself. That's a very tricky business that Yvette Fuentes, one of Roger's collaborators, is looking at. But what we can measure is the quantum state required for the superposition, or the quantum state required for the collapse, the conditions for the collapse. That would mean a quantum state, quantum coherence in microtubules, which should be sensitive to anesthesia. So a process fundamental to consciousness in the brain should go away with anesthesia, and should go away with anesthesia proportional to the potency of the anesthesia, because we know that these gases, which are completely inert and only act by quantum interactions in the brain, we know that they only act by these quantum interactions, and they have different potencies. So one anesthetic might be twice as potent as another anesthetic. So the one that's twice as potent, you should only need half as much as the other one to get the same effect. So by using these relative potencies and measuring the different anesthetics and see how they affect a particular system, we can find a system that matches up with what happens with consciousness in the brain. So we're looking for a biological system that goes away with anesthesia proportional to the potency of the anesthetic. And so we've identified these quantum systems, and in simulation, we found it in that it's Travis Craddock he's now at Waterloo, modeled the 86 aromatic rings, the quantum objects inside each protein, and found that they oscillated and gave off terahertz. And then when he put an anesthetic in, the terahertz was shifted and dampened, and that was proportional to the potency of the anesthetic. So that's the only work that I'm aware of that is shown. It's called a Meyer-Overton correlation, because that's the people back at the dawn of the 20th century showed the potency correlates different potency correlates for different anesthetics on their binding in a nonpolar region, which is a quantum region. So Anyway, but that was in simulation. Then we did a study that was funded by Templeton at Princeton by Arat Kalra, whom you also probably know, where he did tryptophan fluorescence lifetime. He had a microtubule with a laser, UV, and it caused a fluorescence a few short time later. And the delay in the fluorescence and the distance the signal propagated along the microtubule before the emission was inhibited by two different types of anesthetics. So we published that early last year, and now Anirban is looking at effects of anesthesia in megahertz, which must come from microtubules at the scalp in humans, and that work's been going on. And uh, anyway, we're working on the manuscript. It's very interesting. That's all I can say about that right now. So you're right. I thank you for saying it. We've got a lot of evidence in favor of Orch OR, at least for the conditions for that lead to Orch OR. Whereas the other theories of consciousness, which are all based on neurons firings basically as bits, or just pure information, as in the case of IIT, uh, they have, as far as I can tell, zero evidence. They make predictions about which areas of the brain is going to light up with by MRI, depending on whether you believe in IIT or global neuronal workspace. But even one or the other is right, there's more metabolic activity. How do you know that has anything to do with consciousness? Actually, there's evidence that consciousness is a very low energy process, and MRI, which is blood flow, may not have anything to do with it. In fact, in a famous study by Robin Carhart Harris, he studied the subjects in an MRI scanner and who were told to just close their eyes and rest, don't do anything. And while he gave them intravenous psilocybin, and they expected the MRI to light up like a pinball machine, but it was actually cold and dark, like the patient was comatose or the subject was comatose. And then later, the subject reported that they were having these vivid hallucinations and tripping their brains out and all this and that. And yet their brains looked like they were in a coma. So how do you explain that? I explain it by saying that consciousness is at a deeper level, a quantum level in the microtubules, and maybe even psychedelics or meditation, a shift from, I don't know, megahertz towards gigahertz, go faster, more quantum, more non-local, more interactive with the universe. And also in those patients, the EEG was slowed down, in fact, almost flat. So I think that the consciousness is happening at a deeper level, and that's what we see in a near death in our out of body experience. Actually, when everything else stops and even the heart stops, there's this burst of electrical activity, a burst of activity which includes electrical activity, and looks like gamma synchrony, and which, if the patient's resuscitated, uh, then you would suspect that they would say, well, I was floating out of my body, the tunnel, the white light, saw my deceased relatives, but I was calm and serene and so forth, which is very different from agitated hypoxic patients in medicine. So I think that's an example of consciousness going to an even deeper level. And as you go faster and deeper, you get totally non-local. You're actually smaller than the biology, and through entanglement, kind of at large in the universe through entanglement. And I think consciousness can be at large in the universe and entangled, and maybe combined with others through collective oscillations,
Yeah.
and who knows what kind of higher order effects.
Very nice, Stuart. I'd like to steer this conversation in a slightly maybe different direction now. Um, of course, there is all this great research going on consciousness and the brain and so on. But what does consciousness research mean for an individual? How can we understand our place in the universe, for example? Like, will my existence continue beyond death? What are your thoughts on these questions?
Well, according to Orch OR, it's quite possible. I don't claim any evidence, but for the same reason that you can have these out of body experiences, consciousness can. So when the body fails, when the blood stops flowing and the oxygen runs out, the quantum information that's encoded in the microtubules, um, which is actually in space-time geometry, which is where the consciousness is, can dissipate to the universe, but remain entangled by this non-local connection. And it's something like quantum soul. In fact, I wrote a paper about that with Deepak Chopra years ago about near-death and out-of-body experiences, the possibility of afterlife and even reincarnation, because such a entity could find another set of microtubules that it resonates with, and there you have it. And I think there's actually pretty good evidence from these child psychiatry studies in Virginia and also now in India. They're looking at that, and something that if you take a strictly classical view, as all the other cartoon neuron theories do, which consider neurons as cartoons or as just pure information, they could, without a quantum aspect, then it's impossible. But in Orch OR, with consciousness and non-local space-time, yes, consciousness could exist after life and maybe indefinitely, and even, as I said, reincarnation. So until we know for sure that consciousness is a strictly classical computational thing going on in the brain that doesn't extend outwards, then we can't rule out the possibility of consciousness outside the brain existing independently.
Yeah, and do you think there is a role for Eastern philosophy and practices like meditation in the understanding of consciousness?
Absolutely. I think meditation. Um, so we have this idea of this hierarchy of frequencies, and I think, and actually going back to Richie Davidson's experiments, I forget how many years ago, on the Dalai Lama's best meditating monks, he showed that they had a baseline EEG. So I'm just going to go to the slow frequency range now, the EEG. So instead of 40 hertz, their baseline was 80 hertz, something like that. And when
Yeah,
they
that was
measured,
almost a couple of decades ago now, wasn't it?
yeah, yeah. But I think, so they went higher in frequency, and of course, in their altered states. I think actually, because of what Onderbaum's discovered on these higher frequencies, that EEG will be obsolete pretty soon, actually, and we're going to be looking at these much faster frequencies, and it'll be really interesting to see what happens in altered states with these. For example, in Carhart-Harris experiments, the slow EEG went away, but what was happening in the megahertz, gigahertz, and terahertz, or even faster? Maybe that's where they shifted. And the same thing with meditation or altered states. So when I was I think I was in med school actually, I read a book about a Tibetan monk who did astral projection. I read later that it was all made up, I think, but anyway, maybe it was, maybe it wasn't. But he talked about astral projection. But there's also this pretty good evidence for remote viewing and all this stuff. So I think these non-local consciousness effects are real.
Yeah. Uh, Indeed. Okay, so since we have limited time, I'm going to request you to say something about the Center for Consciousness at the University of Arizona and its activities. How did that really come about? And the center has been organizing, in fact, you and another member of the center almost single-handedly or double-handedly, as you want to call it, organize these great conferences which have been running for 30 plus years. That's really amazing. I congratulate you for that. You know what? Speaking of TSC, it reminded me of David Chalmers' recent plenary talk, was it, at TSC 2024, where he said that in the 1990s, he went to one conference which was the theme was consciousness, and that was organized by the Bhaktivedanta Institute. So it seems that Bhaktivedanta Institute was in this consciousness sort of studies since the very beginning of this modern era of investigation of consciousness. So I, again, also congratulations Bhaktivedanta Institute for Higher Studies. So to really their efforts on probing on what is consciousness and moving this forward. But just some tidbit that I wanted to share here.
Yeah, well,
But
let me
Stuart,
let
yeah,
me
tell us about this center and tell us about the Science of Consciousness conference. How have you been really doing this, and what do you see as the future of these conferences of this center, especially in motivating the younger generation to take up this topic for their careers?
Okay, well, let me first respond about the Bhaktivedanta conference, which I think was in San Francisco, and it did precede our first conference. And I didn't know Dave was there, but I think Henry Stapp was there, and I was introduced to that group through Henry Stapp, who was a very well-known physicist, who was very prone oriented towards Eastern philosophy, and also that consciousness caused collapse. So I did know about that, and there were conferences on consciousness within Eastern philosophy for sure, occasionally in Western philosophy, very rarely in neuroscience, because most of the 20th century psychology and neuroscience was ruled by the behaviorists, and consciousness was quite literally a dirty word because you couldn't measure it, and if you wanted to get published and get promoted and get grants, you couldn't mention it, so it was banned quite almost literally. But then in the 80s, in addition to the Bhaktivedanta Institute and others on the eastern side, um, uh, prominent people like Francis Crick, who discovered the structure of DNA, Dan Dennett, the philosopher who wrote this book, Consciousness Explained, which really kind of explained it away. It was very computationally oriented. And Roger Penrose, who wrote The Emperor's New Mind, the book I mentioned before, which attributed consciousness to a process at the very basic level of the universe, which I'm partial to, of course. And also Gerald Edelman about recurrent processing, and he won a Nobel Prize for immunology. So three Nobel Prize winners, and then Dan Dennett, probably the preeminent philosopher of our time, at least prior to Dave, and then wrote books in the late '80s. So it kind of came out of the cupboard, as they say, to some extent. And in 1991, I had organized a conference, a NATO workshop on Froehlich coherence. So, and when I did that, I said, I'm never doing another conference. There's so much work; it's just not worth it. But a couple years later, and then email appeared, and people started talking about consciousness online. There was a discussion group, PsychED, and then the Journal of Consciousness Studies appeared. So I said, you know what? We should have an interdisciplinary conference on consciousness. And so I approached a couple of my colleagues, Al Kazniak in psychology, and Al Scott in mathematics, who was into emergence and wrote a book called The Stairway to the Mind, and Jim Laukus, who recently passed, unfortunately, who was the conference manager. And we organized the first conference at the in the hospital auditorium because that's where I worked, and it was seated 350 people. I don't think we used email then. It was mostly by fax and word of mouth and this and that. But we filled the auditorium and 350 people, and I mistakenly made the first day philosophy, the second day neuroscience, third day cognitive science, physics, math, and then experiential. It's much better to integrate it now, which we learned. But the first morning, the first two philosophers were mainstream philosophers who read their paper without eye contact or slides, and the interdisciplinary audience was kind of falling asleep and getting very restless. And then the third speaker was Dave Chalmers, who had lobbied, was unknown pretty much, but had lobbied me for a plenary slot, which I fortunately gave him. And he popped up and gave this amazing talk about the hard problem that, things like memory, attention, behavior, reportability, they're difficult, but they're not, but they don't compare to the really hard problem of consciousness. So that kind of sparked galvanized the movement. And so the next year, I wasn't going to do it again, but nobody would do an interdisciplinary conference. They either want to do very computational or very kind of experiential, one or the other. And I thought really we had to bring all this together. So I said, okay, we'll do it again in Tucson, but in 2 years. We can't do it every year. But in the meantime, somebody popped up, a psychologist from Italy, Chloe Tede Ferretti, and she organized a conference in '95 that we lent our name to and co-sponsored. And I went as a delegate in Italy. And then in '96, we moved to the convention center downtown, and it got big, up to almost 1,000 people. And it's continued ever since, alternating between Tucson in even numbered years and odd numbered years somewhere else. So in 23, it was in Sicily in Taormina, and in 25, it'll be in Barcelona. We just had the 24 in Tucson at the Ventana Canyon Resort, and we'll be back there in 26. So it's the 32nd or 31st, depending on how you count, because in the COVID year, I guess it was 21. We had a special conference on Roger Penrose on the occasion of his 90th birthday and Nobel Prize, which was a special deal. So we've been doing it about 32 years, and another conference, ASSC, popped up. They were more computational. They didn't want anything to do with the Eastern stuff or the psychedelics or any of that, or certainly not quantum or anything inside the neuron. They were so anyway. They started a few years later, and over the 30 years, it's really unfortunately diverged because they're very materialistic, computational, very AI oriented. Because if the brain is nothing but a computer, then AI will be conscious, no problem. And and then we've included all that, but we actually look at the neuroscience much more rigorously. We look inside the neuron for the microtubules, where we have these not just hertz oscillations, but kilohertz, megahertz, gigahertz, and terahertz. And I keep telling the computationalists that it's like when they go to the symphony, they're only hearing the low bass. They're only hearing the drums and the deep percussion. They're not hearing the piccolos or the violins or anything. So they're missing, but they're only looking at the very, very slow end of what's going on in the brain. And again, I think I think that at least metaphorically, consciousness is way more like music. So there's been that digression, and now where we're going is well, in a couple of directions. Number one, trying to make a connection between consciousness through quantum biology and the fine scale structure of the universe through not just the structure, but also the oscillations and the dynamics and so forth. So people like Nassim Haramein and his group, and Rupert Sheldrake, and Federico Fagin, who Avi Elitzer, and Don Hoffman, all these people who have the idea that we're connecting somehow to fundamental level of the universe. So they're all going to be there. Roger will be there. He'll be zooming. He's almost 95 now, I think, or 90. Anyway, he'll be presenting by Zoom. And so that's kind of where the direction we're going, along with a different approach to AI. And that was started by Anirban, who has a project going in India where funded by the Indian government to build a self-organizing warm temperature organic quantum computer, and which then you have to interface with it. But and now I've heard other groups are doing that, and I think even Microsoft and maybe Google are looking at that. And I think, if you have a warm temperature organic or not quantum computer, that would go a long way that would mean a lot. So I think you originally asked me about what would this tell us about our place in the universe, and I think what our theory says, I don't know what the other theories say. I don't think they can answer that. But what our theory would say is that our consciousness is actually like waves and ripples in the fine scale structure of the universe, much highly organized waves and ripples, but a process in the fundamental level. And so it goes down in scale and faster, faster. So we have this hierarchical thing. And that's very, very simpatico, I think, with Eastern philosophy. In fact, I have a slide of this hierarchy that we've developed with the biology, alongside a slide of the five koshas in Indian philosophy, where as you go deeper, smaller, faster, you get higher and higher consciousness. And that, I think, and then eventually you get to Brahman, the ground of being. And in our view, and I think it's the same thing, you go faster, smaller, deeper, and eventually get to space-time geometry. So, I'm kind of equating Brahman and space-time geometry to some extent, and I hope that doesn't offend people. I'm doing it because I think one's just a different way of describing the other.
Yeah, there may be some ends that might be meeting between East and Orch OR, who knows?
Oh, I think so, for
But
sure.
yeah, I think there is one important topic to touch on, and I'd like to just ask you very quickly your thoughts. Is currently, as you might know, we do not see any important topics like mind, consciousness, reality being taught or discussed extensively in colleges and universities. So, how should we go about educating the world on these topics and developing formal educational programs? And I know that you have been very passionate about education in consciousness. So, what are your current activities encompassing the education on consciousness, reality, and so on?
Well, we have an undergrad program a curriculum program in at the University of Arizona in consciousness studies that's now an undergraduate minor. So we have three classes, and if a student takes those classes, he or she can have a minor in consciousness studies. And we did that through the generosity of Eugene Zhang, who's been very kind to us, and he was particularly interested in education in consciousness studies. And I think so that's our effort. That's going to continue. That's right now in the College of Social and Behavioral Sciences, but it involves many other programs. That's run by my friend Tom Bever, who is an education expert. So. That's what we're doing. Hopefully that'll catch on. And I think our conferences will help develop this. You know, it doesn't help that we have such a divergence of opinion. The reductionist AI types, don't want to hear about anything outside the body or anything like that, or anything quantum, because it kind of ruins their story. But as far as consciousness, I'll say that we have the evidence and they don't. So I'll leave it at that.
Yeah, very nice. Uh, as I like to call it, there is just one single textbook for study of consciousness that I know of, which is University of Cambridge. But there should be many more because this is one of the most important topics that we need to study actually, and bring this to mainstream education and universities and so on. So, anyways, all the best with this new set of courses that you've developed at the University of Arizona, and it's quite a useful effort. And maybe some of us can collaborate in getting this forward to the next level. Okay, so that's been a wonderful journey for you, Stuart, at the University of Arizona, I'm sure, and continuing all these efforts pertaining to consciousness. I think that everyone in their lives should really ask, what is really consciousness and what is my journey, right? So, in closing, I'd just like to ask you whether you have any message that you would like to give to the intellectual audience here of this podcast series, who are so much interested in these very intricate topics, right? Especially consciousness. So, any message for them, Stuart?
I do want to mention one other project that I'm partial to. That's a bit of a digression, and that is Alzheimer's disease, because medicine and pharmacology have really messed this up because there's two types of lesions. One is outside the brain, these amyloid plaques, and then there's the outside the neurons, the amyloid plaques. Then inside the neurons, the microtubules have fallen apart. The tau falls off, microtubules disassemble, the neuron shrinks, you lose synapses, you lose memory, you lose cognition, and the whole brain shrinks. And the drugs aimed at the amyloid plaques have done nothing. They're expensive, they're toxic. There's a way to resonate the microtubules to regrow, and that is with applying painless and ultrasound to the scalp. And these are the same waves that we put into the woman's in the uterus to see the fetus, and they bounce harmlessly back. But the point is that their ultrasound is megahertz, which is the vibrational resonance frequency of the microtubules. And studies have shown that you can induce repolymerization of microtubules. So a study just came out last year, a clinical study of ultrasound for Alzheimer's patients. They got better clinically, their memory improved, and follow-up MRI showed that their brain had regained size. After shrinking from Alzheimer's, it actually regrown. And the only way I can think of that happening is by stimulating the microtubules in all those neurons to regrow and repolymerize. So I'm trying to get a project going with the California Institute of Human Sciences and IONS, and in California, and some other people. And that's something I want to do. It's on my bucket list to put a dent in Alzheimer's, because I think it's a fairly easy, inexpensive, safe, non-invasive way to do it. And it's just that, well, I don't want to start criticizing Big Pharma or anybody like that, but they've been barking up the wrong trees for too long, and it's time to try something different. And this could be it.
Fantastic. Any other messages for our young listeners here?
Astrobiology is going to be a big science of the future. I'm working in the Arizona Astrobiology Center with my colleague Dante Loretta, who was in charge of a NASA probe that went to an asteroid and brought back organic molecules, and we're looking for signs of life. And at the beginning, you said, well, how do you define life? And that's exactly what we're trying to do. What are we going to see in these molecules that would tell us that that's how life began? And we have some ideas and some clues already, but I have to keep quiet about that. And so maybe next year we'll have some significant news in that front. I'm
Very
Lord.
nice, Stuart. It was a pleasure conversing with you in this podcast, Stuart. So thank you very much for being here, and thank you very much to the BIHS for inviting me to be the host. We're going to close this today, and I'd like to say that the BIHS will be back next month again with podcast number 4 in this Insight Stream series. So stay tuned for more information on that. With this, I'd like to thank the organizers here and, of course, our very esteemed guest, Stuart Hameroff. Thanks. Have a great day, everyone.
Thank